All right, so let's look at exercise 3. This is from section 3.3. So just like exercise 1, we're given some characteristics about a function and asked, so whereas in question 1, we were asked if there are absolute maximum and minimum points, this time it sounds like they're taking for granted that they exist, but that we have to find out where they are. So this first question, we have that f prime of x is at most 0 for all x in some interval a, b. So what does that mean about where the absolute max and absolute min on the interval are? So one thing I'll point out here is that we have a function that's differentiable everywhere on a closed interval. And because of that, because it's differentiable, it has to be continuous everywhere in a closed interval, which means that the absolute max and the absolute min have to be achieved. They have to exist. So now, can we say anything about where they are? So let's try to draw a graph here. So it might be tempting to say that, if we look at A and B, A has to be strictly above B. And that's definitely possible. One thing I want to make clear here is that this is a weak inequality. So f prime of x could be less than 0, but it could also be equal to 0. What if it's equal to 0 for all x in a, b? Well, then if your derivative is equal to 0, then you have a horizontal line. But what I want to point out is that in both of these graphs, both of these possible functions I've shown here, and there are infinitely many others, the global max has to happen at A. The global min has to happen at B. What I'm not saying that one of those that is possible that, in this one case here, where you have a horizontal line, is that the global maximum and the global min are the same value. That's one little consideration to worry about here, but that doesn't change the fact that the maximum has to happen at A, the minimum has to happen at B. I'm given the special dispensation that it's possible for the global max and the global min to happen at both A and B, but only if they're the same value. All right, part B, G has a critical number C. All right, so such that C is strictly between A and B, and G prime of X. Okay, so let me draw a sign chart here. There's a lot of information to worry about, so let's get some organization. So these are X values. I want to look at G prime. I have a critical number at C, so my derivative is equal to 0. What's true about the derivative to the left of C? It's positive. And how about to the right of C? It's negative. So can I translate that into a graph? So here's A, here's B. Hopefully from my sign chart, I can convince you that at C, I have to have a relative maximum. So G of A has to be lower than C. G of B has to be lower than G of C. So I have to have a function that looks like this. So I think because of that, our global max, or they don't use the word global, do they? The absolute max is at X equals, or is at G of C. That has to be true. Again, this is a closed interval AB, so I have to have an absolute min. So where is it? So we have two choices here, and I don't think we can go any further than that. Because basically, our global min is going to be either at A or B. Because after C and B, like from to the right of C, the function is decreasing. So the further right I go, the lower values I'll get. From A to C, the function is increasing. So the further left I go from C, the smaller values I'll get. So the absolute minimum is going to happen at whichever one of those is smaller. And I could make either one of those things happen. So in the graph I've drawn, G of A is smaller, but let's say I draw this graph. I still believe I have a critical point there, but it all depends on what exactly the first derivative looks like away from C. C, H of A equals H of B. Okay, and H double prime of X equals or is less than 0. So let's do this. Let's draw a graph as accurately as I can. So A, B, and I have equal Y values here. And I'm also told that the second derivative is negative, which means what? I have a function that's concave down. So if I have a function that's concave down, so one thing I want to point out is that if I have a function that's concave down, is it possible for the first derivative to be 0 or negative? Well, no, because that is going to make it impossible for H of A and H of B to be the same number. So because of that, I have to have at H prime of A, I have to have an increasing function, and then which then decreases so that H of A and H of B are at the same level. So because of that, let's answer the question, where is my absolute maximum? The only thing I can say about the absolute maximum is that it's on the open interval AB. Basically, I could cook up a function that that can take a maximum anywhere in between these points. So this one's kind of like 2/3 of the way from A to B, but I could, let's just illustrate this here. I could have a function that looks like this. This is also concave up, or sorry, concave down. What if I go even more drastic? That's not a function. But that's also concave down. And I could do the same thing on the other. Basically, what I'm illustrating here is that I could make the X value the absolute max as far left, as far right as I want, but I can't have it occupy A or B. Where's the absolute minimum? That's going to come from basically you have to the same value, H of A and H of B. So because this function is concave down at the endpoints and everywhere in between, then I have to have a function that increases from H of A and decreases back down to H of A again, essentially. So the endpoints have to be the absolute minimum. And finally, all right, what am I told here? I'm told that P of A is positive, P of B is negative, and the critical number, okay, so I got a lot of, let's make a sign chart because there's a lot of stuff going on. So P prime, again, I'm looking at A and B. That's my closed interval. What's happening at C? C is a critical number. I have a first derivative equal to 0, and it looks like I have a function that decreases that point and increases thereafter. I'm also told that P of A is 0. No, sorry, P of A is positive, and P of B is negative. So let's try to draw a graph now for my sign chart. P of A is positive. So let's say that's P of A. P of B is negative. And that there's a critical point at C. So let's say this is P of A. This is P of B. And then I have a critical point at C but I have to decrease to that point and then increase back to P of B. So I think my function has to look like this. So decrease down to a critical point, and the reason I'm making it so low is because I have to increase back to P of B. So let's just make sure that I have to convince you that I've done all these things. P of A is positive, yes. P of B is negative, yes. Critical number C. This looks like a critical number, right? So this is P of C, and it's a relative minimum. Does this match my, so does my function increase or decrease from A to C? Yep. Does my function increase from C to B? Yes. So I think because of this, I have to have an absolute max at P of A and an absolute min at P of C, and then P of B has to be somewhere directly between them because it can't, P of B cannot possibly be positive, so it can't be as big as P of A. And I think that's it. Yes.